Alright, so today we're going to be finding the point of intersection between two linear equations. So the first thing we need to do is we need to look at our two equations, and we're going to want them to set them equal to each other. So the only way to set them equal to each other is by having one variable on one side and everything else on the other side. So for example, we see that there's a y in both equations, and we see there's 2x in both equations. So what we need to do is isolate for one of them. So since we would have to isolate the 2x to make it just x, and the y is already separate, we're going to just isolate for the y. So the first equation's pretty easy to separate it. We're going to have our y is equal to 7, and in order to get this 2x onto this side of the equation to isolate for the y, we just have to subtract 2x from this side, which will cancel it out, which means we also have to subtract 2x from this side, which will add to our equation over here. And for this one, we want to have a positive y to match this positive y. So in order to get a positive y, we know that since this is negative, we'll have to bring it over to this side. So we're going to set this as 2x is equal to y minus 5. And now to isolate this y, we're going to add 5 here, and we're going to add 5 here, which will give us y is equal to 2x plus 5. Now that we've isolated for y, what we're able to do is set the equations to equal each other. So we'll have 2x plus 5 is equal to 7 minus 2x. Now what we're going to want to do is we're going to want to solve for our first variable, which is going to be x. So in order to solve for x, we'll see that there's a 2x here and it's a negative. And we will most of the time want to work with the positive versions of the numbers. So we're going to bring it over to this side by adding a 2x here, and as well as adding a 2x here, because this will cancel with this, and whatever you do to one side of the equation, you have to do it to the other side. So we'll add 2x here, plus 5 is equal to 7. And now we want to get rid of this plus 5, so we're going to subtract 5 here, and subtract 5 here, to give us 2x plus 2x is equal to 7 minus 5. And now, since they have the same variable of x with both to the degree of 1, we're able to add them perfectly together to give us 4x is equal to just 7 minus 5, which is 2. But we're not done, because we still have to solve for x by itself. So in order to do that, what we're going to do is divide both sides by 4. Because dividing this will cancel the two 4's, leaving x by itself, giving us x equaling 2 over 4, which, if you notice, is just 1/2. Now we know that our x for the point of intersection is 1/2. But what are we going to do with that? What we're going to do is we're going to look at one of our equations before. I'll go with this equation right here. Doesn't really matter which one. I'll pick this one right here, and we're going to substitute our x for 1/2. So we're going to get y is equal to 7 minus 2 multiplied by 1/2. Now that gives us 7 minus 1, because 2 multiplied by 1/2 is just 1, and that gives us y is equal to 6. So we know that our point of intersection for this equation, or for these two linear equations, is going to be, our x is going to be 1/2, and our y is going to be 6. And if you want to check your work, you can go to Desmos and type in your two equations right here, and then it'll show you the point of intersection for our equation, which is 0.5 and 6, which is the same as 1/2 for x and 6 for y.